Morning students, in our earlier classes we study different method of separating component of a mixer, like separation by separating funnel, centrifugation, distillation and fractional distillation. Students, today we will study a new technique that known as crystallization. What do you mean by first crystallization? Students, some salts have water in that salt. That water known as hydrated salt. For example, that is copper sulphate. In copper sulphate, 5 water molecule present. Like ferrous sulphate, 7 water molecule present. In potash alum, fit curry, that also some water molecule present. You will learn how can you write their formula in next chapter. But now I write some formula, then you can easily understand what is hydrated water. Means that water remaining on that crystal. So we can separate those crystals, they have hydrated water by this technique. And this technique is better than simple evaporation. By that evaporation, impurity contaminate remaining on that, because we can't remove all the impurities by filtration or by evaporation. So this technique is better. We will explain in detail after some time. First I write some chemical formula. First one, students, copper sulphate. So I write the formula of copper sulphate. Copper sulphate. You will understand how can you write the formula in next unit, but I write for only you revise. Copper sulphate I write in this way, pentahydrate, 5 water molecule in this. So this is hydrated water. Other compound is ferrous sulphate, FeSO4 heptahydrate, 7 H2O molecule. Other one, students, potash alum. Potash alum. That means common name is Fitcurry. Very useful this compound. And this is a double salt. And that one is potassium sulphate, aluminium sulphate, 24 H2O. I write another formula, that is, washing soda. You will learn in 10th class, washing soda. That is sodium carbonate decahydrate. I write one more example, that is gypsum. That is calcium sulphate twice hydrate. Students, you will learn in detail how can you write this formula in next unit. But this type salt, that is hydrated water. This one is hydrated water found in this. So such type salt we can separate by crystallization. Crystallization is a technique to separate the solid crystal from solution by using a special solvent, or we can take a mixture of solvent. So students, now I am showing you a activity, how can we make crystal, how can we separate crystallization of copper sulphate. We take the example of copper sulphate. Hence, we take approximate more than 5 gram copper sulphate. This one is copper sulphate solution. Student, actually this is pure copper sulphate, but we want to crystal from impure copper sulphate. In our laboratory available pure copper sulphate, so we dissolve this copper sulphate in minimum amount of water. Means I dissolve this copper sulphate in the water to make the solution. So this like we prepare the solution. So I dissolve this, all the salts is dissolved. Students, other factor is a saturated solution. What do you mean by saturated? We already studied this. Maximum amount of a solute can dissolve. Maximum amount of a solute can dissolve at a given temperature. That's known as saturated solution. So we can't further dissolve that salt. Means after saturation point we can't dissolve the salt. So this salt I put in china dish. In this, all the salts I will put in china dish. Because first we have to separate. Why? To remove impurity. But this salt is pure salt, so there is no impurity, so no need to filtration. But if any impure salt, if there is further impurity, that is separate by filtration. So now we heat this on a tripod stand. It takes some time. When we heat, then after some times, when it boils, a point of crystallization occurs. A point of crystallization, how can we identify? When the salt is heat, then we use this glass rod, and glass rod when we blow, that some crystals are stick on the glass rod. After that we can say that point is crystallization point. And we placed overnight for that solution for making crystal from mother liquor and separate by then filtration. Students, I will show you this after some time, and you can see the crystal tomorrow. In tomorrow class I will show you the crystal of copper sulphate, how can formation. When this is strongly heating, then some water is evaporate, a point of crystallization occurs. How can we find the crystallization? When we blown by the glass rod, on the glass rod, then some crystals are deposited on the surface. I will show you after 10 minutes. Students, by crystallization technique, we can separate the following things. What are the advantage of the crystallization? Then simple evaporation. We know in simple evaporation we can separate the salt from water. Means raw salt we prepare from salty lake, from that is in Rajasthan, that is Sambar lake, we prepare that salt, and other one also in that coastal area, that is we also prepare that raw salt, but on that raw salt have impurity. So that impurity can remove by the crystallization process. And other advantage is it is better than those solids are decomposed on heating. Those solids are decomposed when we heat directly, they are decomposed, so that is better than evaporation. Because sugar, like sugar, when we heat, then sugar change into black color. Because sugar have carbon, all are is removed out. That is shared on heating when it dryness. Other one, by evaporation, some impurity after remaining filtration, that contaminate that solid. So crystallization is better than evaporation by these two advantages, and we can remove salt from seawater and then further purification by crystallization technique. Fitkari potash alum, you know that is very important salt for use for drinking water disinfection, sedimentation of the particles, we use that potash alum, Fitkari. So this potash alum also can purify by crystallization process. So students, this technique you will study in detail 11th and 12th class, and there is practical also. How can you prepare ferrous sulphate crystal, copper sulphate, potash alum crystal. And this same process we apply. We take impure crystal, then dissolve in water or other solvent, then we filter, and then further heating at a point of crystallization and place overnight, and we get a special shape of definite types crystal. And you can see that tomorrow this copper sulphate, crystal a definite shape. So in this way, this crystallization process occurs, and you will learn in 11th and 12th class. Students, now crystallization process is start, and it's required only few times, and this crystals, this solution be placed overnight. Then you can see tomorrow morning I will show you the crystal in next video. So this process known as crystallization, and we can separate those crystals have hydrated water. Those salts have hydrated water, we can separate by this process. Now students, how can we purify the waters? From water purification system in water works. In our house we get the drinking water. What the process? How can they separate the water? Means how they purify and what are the process? So students, in that water works, at first there is a reservoir. They collect the water from by canal or groundwater or anywhere, almost canal water. Then this water is allowed to in a sedimentation tank, a large tank, and further in sedimentation tank, solid particles are settled down for some time on their own because they are placed for some time. Further, this water pass through in a loading tank. In that loading tank, we know earlier we study what is suspension. Some particles also suspended on that water. Then we use like potassium, fitcurry. That salt easily can they help to sediment the suspended impurity on this tank. Further, we pass this water in a filtration tank. In that filtration tank have 3-4 layers. First have large stones, that is cast stone. Then further small stone, gravels, and then fine sand. We take 3-4 layers on this, and then allow the pass water through this system. So we get in this water. But that water is not free from germs. We get pure water, but after the filtration temp, there is remaining some impurity like bacteria, the germs. To destroy all the microbes, germs, we pass through in a chlorination tank. We put some bleaching powder or chlorine gas pass. Due to that, bleaching powder release chlorine gas, destroy all the microbes, and then that water we supply in our houses. Students, by this process you can purify the waters in your homes, save water, because water is a very natural resources. So in these days rains is going on, so collect that water and motivate and inspire other parents to save the water, minimum use of the water. And if any, generally we open the tap and we forgot and we are doing other work, so that time we should be close the tap. So natural resources we should be saved. Students, our new topic is physical and chemical change. In our earlier class 6th, 7th, 8th, you know what is physical and chemical change. Now I am showing you on activity based, that is practicals, what are physical and chemical change. Then we summarize the difference between physical and chemical change. So students, now you see the activity. You can see I placed ice on this container, and you can see the state of ice in solid state, but it is melt because at room temperature, that is 25 degrees Celsius, and ice temperature 0 degrees Celsius, so it is melt. So melting of ice is which type change? Means only physical state change, that change known as physical change. Substance remaining same. Compound is not change in this. Water is water, either in solid, liquid or gaseous state. So such type change known as physical change. Other example are melting of ghee, melting of wax, and those substances are melting normally, that are physical change. Now I am showing you some chemical change. So students, this one is lead nitrate. Lead nitrate chemical I placed in this beaker, and I want to make the solution of lead nitrate. So you can see in our earlier class we already prepared this such type solution. You know, solution is a homogeneous mixture, uniform composition throughout the layer, and this one is potassium iodide. Already make a solution. I mix in this potassium iodide in lead nitrate. You can see what happened when I mix. Then you can observe this type, yellow precipitate, yellow color, yellow precipitate observes. After some time it is settled down at the bottom. So this type change is chemical change, because a new substance is formed, color change, and the compound also change. When we write in a reaction, that known as chemical reaction. Students, I am showing you another activity. That one is sodium sulphate. So in this I make the solution of sodium sulphate, that is clear solution, means homogeneous mixture, uniform distribution. In another beaker I take barium chloride. Barium chloride. So in this is barium chloride solution. So you can see that also a clear solution, means homogeneous mixture. What happens if I mix sodium sulphate and barium chloride? So they react to each other. So you can observe what will happen. This one is white color, white precipitate, barium sulphate, white precipitate. So this is a change, means chemical change. The color, precipitate or any gas release out. Such type reaction known as chemical change. Students, now I am showing you burning of magnesium ribbon. You know, this one is magnesium ribbon. So but it is black color. So at first we have to clean the surface. So this is, I remove the color, and then we will burn this magnesium ribbon. So you can see what happened in this. You in earlier classes we also seen this activity, burning of magnesium ribbon. See the burning of magnesium ribbon. Students, you can see what happened. Dazzling white flames release. So this also a chemical change, and that magnesium oxide is formation. When burning this magnesium ribbon, it's formed magnesium oxide. But this dazzling flame is dangerous for eyes. And we get white ash in this after burning of magnesium ribbon. So students, you can see the difference. This one is magnesium ribbon and this is magnesium oxide. After burning, a new substance is formed. So such type change known as chemical change. If you represent this change in a reaction by writing the symbol of the compound and the elements, then this is known as chemical reaction. So chemical change known as chemical reaction if you represent by symbolic representation of a compound and element and by putting an arrow mark from reactant to product side. You will study this chemical reaction detail in 10th class. These all reactions we will study in 10th class. Students, now we summarize the difference between chemical and physical change. In physical change, we can see the ice is melt. So this one is ice, your solid state, and it is melting. So you can see it change into liquid state. So this is the reason. What are the reason? Because this ice takes energy from my hands and it's converted into liquid state. You can see easily. So this type state known as physical change. So in physical change, we can say physical state will change. Physical state will change. Solid change into liquid and liquid change into gaseous. They can convert to each other. But in chemical change, physical state may be changed, may not be changed. In chemical change, physical state may be changed or may not be changed. But a new substance is formed. In chemical change, new substance is formed. Either a color change or precipitate or temperature change in that type reaction, that known as chemical change. For example, if you write melting of ice, so students, how can we write ice? We know ice, that is a water. We can represent that in a formula. Ice means solid state. This one is ice. It's when heating, it's converted into water. That also H2O, but liquid state. This one is water. If you further heat, that it's changed into also a water, but in gaseous state, that is known as vapor. So this one is physical change. But in chemical change, you can see that is magnesium ribbon. I burned that one, and this is white as known as magnesium oxide. So how can we write this chemical reaction? Suppose that is magnesium, I write Mg, and it's burned with air, so it's required oxygen, and it's converted into magnesium oxide. If we balance the reaction, so then we get this type you studied in 10th class. So there is magnesium, that one oxygen, that is magnesium oxide. So they are a new substance. This one is a new substance. We can say new substance. So in chemical change, new substance will form. The reactant combined change into this type. So other examples are, these examples we already seen, that is yellow precipitate of lead iodide. Students, now you don't worry to how you write the formula of lead nitrate and potassium iodide. We will study in next chapter, and you easily can remember that formula. Other one also, I can show you this white precipitate of barium sulphate. This is lead iodide, yellow precipitate. So these are in your practicals in 9th class in activity. How can change, what are the color? So this one is physical change, only physical state. Other one, this is reversible. I can write if this ice convert into water and water convert into ice. So normally physical change are reversible process, both sides. But chemical change normally, chemical change, for example, this ice, this magnesium oxide not change into further magnesium. So normally they are irreversible. These are chemical change are irreversible. Other one, in their physical state, these are main difference. And if you write burning of paper, burning of fuel, That are example: burning of paper, burning of fuel, digestion of foods. You can write here examples: burning of paper, wood, fuel, burning of paper, wood, fuel. Other one, digestion of food in our body. That is chemical change. But physical change example: melting of wax. Example are melting of wax, ghee, any substance melting. Such types are physical change. So in physical change, there is no new substance is formed, only physical state will change. But in chemical change, new substance will form. Chemical change may change, physical state change or do not change in chemical change, but product is definite change. New substance will form. So such types change known as chemical change, and we will study detail in 10th and higher classes. In our 9th class, this only you write the summarize. So students, tomorrow we will study elements, compounds, and tomorrow we will finish your, that is, second chapter. If you have any problem, then write in comment box. We will solve in next video. Thank you. Have a nice day.